Hello mariners, this is Captain Kulkarni and we are having the next video which is of ballast water management D2 standards. I already made first video on D2 standards and this is the second video in which we are talking about physical disinfection and we will continue with the overall view first of all. So the mechanical ballast water treatment has already been explained to you in my previous video. In this video, we are dealing with the physical aspect of it, in which three types of technologies I am going in detail: thermal, ultraviolet radiation, ultrasound, cavitation, de-oxygenation and vacuum. Now, mind you that sometimes a single technology is used, sometimes it is two technologies which are used. The next video which we are going to do, we will be talking only about the chemical ballast water treatment. That will be the last which comes to the ballast water treatment process and the ballast water management. After that, the next video which I am coming up is regarding the ballast water management book. So, which are the 6 method? Number 1 is pasteurization. In pasteurization, which companies are using that is Bawat A. Ultraviolet radiation, which companies are using is Pureballast, Biosea, AQUARIUS. Number 3rd is ultrasound technology, which is used by 3 companies: Hielscher, Ultrasonics and Maritronics. Number 4th technology is hydrodynamic cavitation, used by HyCa Technologies and NCL Innovation. Number 5 is de-oxygenation, is used by Maritronics Alfa Leval, and vacuum is used by Hielscher, Ultrasonics, Xylem and Nepia. Now, one thing I would like to tell you that one company is making the ballast water treatment using different technologies, or they are adding 2 technologies together. So, don't be surprised that they have made this one also and that one also. That completely depends what the owner's requirement is there. That is equally important. So, let's look into that now. The first one is the thermal treatment or the pasteurization. Now, what is pasteurization? Like the milk, what we are heating up to a certain temperature, so that all the organism which is there inside is getting cleaned or it is getting dead. Same is applicable here. You are heating it up to a certain temperature and then all the viable organism which is there, they are all going away. Sayonara, bye bye to you. Okay. There are a lot of advantages of this pasteurization method: no further treatment, filtering, and then in this the media is continuously throughout the whole process is making it efficient and straightforward. So, this is the first method. Okay. Then why they are saying pasteurization is good? Energy efficiency. Your ship's waste energy from engine gets a second life. By treating ballast water in voyage, you optimize energy usage. Simplicity. Pasteurizations keep things refreshingly simple. Okay. Multiple treatment mode. With pasteurization, you have got option whether it is ballast inline, deballasting inline or tank to tank treatment. You can do anywhere. Minimal spare parts. Some technologies require too many spare parts, some technologies requires minimum spare parts. Salinity and turbidity independence. Pasteurization doesn't care about the salinity, how much salt is there. Okay, you can have from 1000 to 1025 or 1028, that is not a problem. It is like a chill friend who adapts to any situation. Crew friendly. Members can operate the system without decoding cryptic manual. You don't have to study too many manuals. You can use it. Now, USCG has given an approval, and a company, this is a Danish company called Bawat, and they are using this technology and it is well used on board. These are the photographs which you can see for pasteurization. and how this technology is getting used is shown here, and the heat is coming from the boiler, which you can see, and how the technology is working. The next one is ultraviolet radiation. Ultraviolet is a non-visible light which has got a shorter wavelength than visible light. Ultraviolet light wavelength range is around 254 nanometers, between 100 to 400. Okay, UV lamp surrounds the chamber through which ballast water flows. As the water passes through this UV chamber, the UV light damages the DNA of the microorganism. If you see my old videos, we are all talking that the ballast water treatment is all about killing or neutralizing the microorganism present in the ballast water. This damage makes the organism inactive and prevents their reproduction. In other words, UV treatment sterilizes the water by rendering harmful organism harmless. This is how it is done. Ultraviolet radiation, the microorganism continues to live, but they are unable to reproduce or replicate themselves. If microorganism is unable to reproduce itself, it is rendered harmless. Ultraviolet intensity of the doses are usually measured in millijoules. The dose of ultraviolet lights that needed to inactivate E. coli, which is about 7 millijoules per centimeter, and such as viruses such as entris, adreoviruses, hepatitis A and rotavirus SA11 can often require very large ultraviolet doses for inactivation. You can have a look at this link which is speaking, this is on YouTube video. This is regarding the ultraviolet radiation. Go from timing 248 to 4, and it is talking completely how does this particular technology work. Ultraviolet radiation advantages and limitation. Advantages: this is environment friendly. UV treatment doesn't involve chemicals. It leaves no harmless residues. Effective: UV lights act quickly, efficiently, neutralizes a wide range of microorganisms. No regrowth. Ultraviolet treatment prevents regrowth. Ultraviolet light disinfects, creates no halogenated disinfection byproducts. Ultraviolet light also creates no ultraviolet light residue. Now there are few limitations, and with this there is a system limitation. For ultraviolet light disinfection to be effective, ultraviolet waves must travel in close proximity to water than being treated. UV lamps are either grouped in non-contact panel with the water passing underneath the panel, or they are submerged directly into water with the water moving around and between the lamps. When the lamps are submerged into the water, the lamps must be encased in quartz tubing. You can see the next video. In the next video, which is given by Wartsila, the Wartsila has UV system in which they have explained how exactly the water is passing through the UV tubes, which is clearly seen. Have a look at this video. It's a beautiful video. The next third system which is used is ultrasound. We are also using sound, and this ultrasound is, sound can be described as mechanical energy transmitted by pressure waves in a material medium. Sound can be described as a form of energy, or a sound is said to be mechanical. This distinguishes sound energy from other form of energy such as electromagnetic energy. Ultrasound is cyclical sound pressure with a frequency greater than the upper limit of human hearing. Exposing liquid to higher mechanical pressure waves or sound waves forces as acoustic streaming, stable cavitation and transitant. Unstable or inertial cavitation can be induced. If we go further, ultrasonic ballast water treatment system uses high frequency sound waves to treat ballast water, effectively killing harmful organisms and pathogens. Here is a brief overview. One is the cavitation process. There are two processes of ultrasound. One is the cavitation process, and second is it is breaking the H2O atom, the molecule into different parts, which is coming. So cavitation is coming next. Let us talk more about the further one. The mechanical physical treatment, these methods avoid use of harmful chemicals, making it environment friendly. Combination of other systems, ultrasonic treatment is often alongside other methods such as filtration or UV treatment to enhance overall effectiveness. This approach is gaining popularity due to high biological effectiveness and environmentally acceptability. Now, what is it? The modern ultrasonic devices rely on transducer which are composed of piezoelectric material. If the potential is altered at a high frequency, the crystal converts electrical signal to mechanical vibration. At sufficiently high alternating potential, high frequency sounds will be generated. When more powerful ultrasound at a lower frequency is applied to a system, it is possible to produce chemical changes. You can see the sound pressure and then the compressed wave and the bubble which the ultrasound is coming. The bubble size is also changing with time. Okay, forces due to surface resonance of the bacterial cell are induced by cavitation. Pressure and pressure gradients resulting from collapse of gas bubbles which enter the bacterial solution or near the bacterial cell wall. In the ballast water, there is lot of bacteria, and this particular pressure gradient which is coming, which is because of ultrasound, is directly hitting the bacterial cell wall. Bacterial cell damage results from mechanical fatigue over a period of time which depends on frequency. Shear force induced by macro streaming occurs within bacterial cell. Chemical attack due to the formation of radicals during cavitation in aqueous media. These radicals attack the chemical structure of the bacterial cell wall and weaken the cell wall to a point of disintegration. They are breaking the wall. Among final products of this sonochemical degradation of water is hydrogen peroxide, which is a strong bactericide. There are no additive introduced into ultrasonic system and no byproducts generated by ultrasonic technology. Therefore, there are no anticipated environmental concerns associated with this technology, in contrast to many processes which are negatively affected when suspended solids of effluent increase. You can see the further effect. Under extreme conditions, water molecule undergo homolysis to yield hydroxyl radicals and hydrogen atoms. Since oxidation by hydroxyl radical is an important degradation pathway, amount of this hydroxyl radicals present in the sonolysis system is directly related to degradation efficiency. Okay, the violent bubbles collapse leading to high energy and sonolysis, and this is how hydrogen peroxide is made. This particular hydrogen peroxide which is there is killing. This is one method. Other method is also the cavitation, which is coming in the fourth one. Cavitation is a special phenomenon in a liquid of any change occurs in the presence in the pressure field over the time and distance. Cavitation can be realized by alteration of flow and pressure. Hydrodynamic cavitation. In hydrodynamic cavitation, flow geometry is changed in such a way that kinetic energy increases at the expense of local liquid pressure, which can make cavities depending on the vapor pressure of the liquid. Cavitation is a dynamic process depending on continuous change over time of the volume and geometry of the bubbles and cavities. So, now we are looking into the fourth one, and here in this figure you can see when the pressure is going up, what changes are taking place in the water molecule. One of the important application of hydrodynamic cavitation is cell disruption. The cavitation effects can be classified as physical and chemical. The physical effect includes generation of shock waves, the water hammer effect, and radial bubble motion. And here they have amplified, and you can see how does the bubble, which is supposed to be round, is getting a cavity inside in it, which is clearly seen. And this, how does this help? This, and first is, how do we make the cavitation? You see from both the sides, number 1 and 1, and the water is coming from both the ends, and it is going and hitting, and it is going inside in a chamber, the chamber is number 2, and finally it is coming out from chamber number 3. And with this hydrodynamics which is there, now the water is getting a lot of swirling, because of which cavitation is taking place. With the cavitation, what we see is, as per the last video, we are getting the bubbles amplified. And then this is the second picture, if you see, is that here in this cavitation you have calcium carbonate scale which is coming out. Cavitation kills biologics by breaking down cell walls, and vacuum stripped CO2 will evaporate pH, creating a low corrosion environment. We can see control hydrodynamics cavitation. Biologics adopt traditional chemical treatment, however, this cannot be adopted to controlled hydrodynamic cavitation. They can, in controlled hydrodynamic cavitation, turbulent fluctuate pressure field is there, and they are using an orifice plate by which you are getting a pressure, and with this pressure everything is getting killed. So we are using a orifice pressure. Now what is the key effect? Highly reactive free radicals are there, localized intense pressure and temperature condition is there, concentrated energy at location of transformation is there, high intensity turbulence, increased transport coefficient is there, order of magnitude reduction in energy requirement for physical chemical transformation which is there. So these are the 4 inputs, and final output is this, and they say it is working. Okay. Now key effect of cavitation zone. The chemical effect of cavitation during the cell disruption are due to generation of free radicals. Their extent depends on the intensity of cavitation, which can be varied by manipulating the operating parameters such as cavitation number, initial concentration of cell suspension, number of passes through the cavitation zone, temperature and viscosity. A cell is likely to get disrupted due to high velocity jet or shock wave produced by collapsing cavity when one is interested in obtaining periplasmic enzyme low intensity. Cavitation which is just sufficient to break the outer wall should be used. Now we either using chemical disinfection, which is coming in the next YouTube video, and we have control hydrodynamic cavitation. Chemicals are we using in this? No, but we are using in chemical disinfection. Size is small, chemical disinfection is medium, cost is moderate, and there it is medium. Safety, this is absolutely safe. Chemical disinfection, you don't know, sometimes it is not very safe. Sludge is getting produced low, and here in both the cases it is low. So this is the comparison given for a person to understand that control hydrodynamic cavitation and chemical disinfection, what are the differences. The next which is coming is de-oxygenation. As the name suggests, de-oxygenation ballast treatment methods involves purging, removing oxygen from ballast tank. The microbes or the organism which is there in the water, they are what you call it, living on oxygen. So remove the oxygen, or simply make on the top of it, make it inert. That is what this is usually done by injecting nitrogen or other inert gas in the space above the water level in the ballast tank. Okay, it normally takes about 2 to 4 days for inert gas to asphyxiate the organism. Now remember something, in other technologies the time period is not that long. Here in de-oxygenation the period is a little longer. This method is usually not suitable for ships having short transit time. Moreover, such a type of system can be used on ships with perfect sealed ballast tanks. If a ship is already installed with an inert gas system, then a de-oxygenation system will require more space on board ships. More aquatic organism requires oxygen for survival. Fundamentally, the process uses oxygen deprivation to kill non-indigenous species contained in ballast water. Current research reveals lowering of level of oxygen to less than 3 milligram per liter will result in effective killing rate of NIS. De-oxygenation typically involves bubbling nitrogen or other inert gases into ballast water to reduce the oxygen content. So on tankers where you are continuously getting inert gas, or even other ships, because the inert gas is getting generated as the boiler is getting used and we can directly put it. So this is one technology. The last technology, the fifth technology is still going on. Marine ecologists at Monterey Bay Aquarium Research have developed a ballast water treatment process capable of minimizing shipboard rust and corrosion while killing most of the 80% of ballast water. If there is no oxygen, there is less chance of rust. And then they say that in case you have a nitrogen generator or an inert gas plant, we can use it, and that will be helpful. The most promising and practical shipboard application of de-oxygenation is involve a removal of oxygen from seawater or bioreactor that contains oxygen, removing the bacteria immobilized on the support matrix through which seawater is passed. A second most cost-effective option utilizes the ship's exhaust gas or de-oxygenation process instead of nitrogen. Exploiting the ability to carbon monoxide or inhibit oxygen consumption will also lead to the destruction of ballast water. The last is vacuum. At the heart of a treatment, a chlorine dioxide generator that delivers a dilute solution of chlorine dioxide to treat incoming ballast water. The fully automated compact generator has a few moving parts and at the same size of all size of system. It simply works a small amount of supply water from the ship's flow through an eductor which creates a vacuum in the mixture chamber. Once the vacuum has been created, two precipitator chemicals flow in the chamber. The supply water becomes a solution of chlorine dioxide that sends the main ballast line. The flow path is animated in our website. We have a company called EcoChlor which is doing that. In simple words, I would say, one will say, what is it in number 6? It is a eductor system. In the eductor system, they are pulling a little amount of chemical, chlorine dioxide, which is because there is a vacuum there, and with that vacuum, it is getting mixed with the water. So this is a mechanical process and a chemical process also. Yes, I agree with that, but let us have both the processes written, how exactly it is done. So that's all for this video. In case you like the video, kindly subscribe. I have got another video coming up on ballast water technology, that is the chemical one. And please give your valuable comments, what exactly, which videos you like to do, and let me know. And thank you very much everybody. Bye for you. Happy sailing, and please